Hi, Jay. Mr. Caso, good. You're back. This is our second session. Let's wait a little bit for Jovi and then Mrs. Mantos. But not to worry. Again, I'm able to record all of this. It's already been recording. So we can just start in about a minute and then they can watch the video also. So we left off last time with the odds ratio and relative risk. And as I mentioned earlier, this is a very important epidemiological statistics that has a strong relationship with chi-square statistics because the philosophical or the mathematical foundations of these two are very closely related. So both the odds ratio and the relative risk compare the likelihood of an event between two groups, but there's a subtlety between odds ratio and relative risk. You actually need to specifically use odds ratio to specific situations or specific research design, and you use relative risk also to a very specific research design, which I will mention. So the commonly used measure of the relative probabilities of disease in case control studies and cohort studies. So the question now is, which of the two is a good match for case control and which of the two is a good match for cohort studies?
Dok, isa dok udah inform ako dok masih mentok ni Pepsia. Kuan di siya kaso di siya check up yung internet connection at kasi trouble sa internet connection niya.
Remind lang siya ng katong na pong pinaka-latest nga email niya. Ang ID is 188-920-298.
Si Daniel, si Jovi. Mantos kaya di kaso kaya internet niya ko hindi connect. Ako informan si Jovi dok.
Ingna siya katong connection nga mo and 188-920-298. That's our new session now. That's the part 2. But let's just proceed because it's in the recording, so they can see this on YouTube. All right. So as I've mentioned, very specific, the odds ratio is for case control and relative risk is for cohort studies. Now, what would be a good mnemonic so that you will remember this? Unsay nindot nga mnemonics para di kakalimot nga ang odds ratio para sa case control nga design. Unya ang relative risk gamiton sa cohort study. Unsay nindot nga mnemonics para di ta makalimot? Para di na to marambol.
ORCC kung kuan odds ratio, then RRC as kung kuan relative risk in terms of cohort studies.
Kung cohort studies. Kaya balog ka ang kuan nabaya sa YouTube. I forgot the name of the guy, but ang iyang suggestion hantod karon wala di ko kalimot. Naingon ra gid siya nako nga para di ka kalimot ang mnemonics kuno nimo nga gamiton sa cohort study are the pirates, because pirates are a group of people, di ba? And then mga pirates moingon sila nga Arr! So there's two R with the pirates, and so it's relative risk kung cohort study kay ang cohort are group of people niya pirates man. Hantod karon di ko kalimot manang wingon jud ko gamito na nako but if you find another mnemonics that will work for you, do it. But since then nga nakadungog ko nga kana bitang lecturer nga naingon siya nga para dili jud ka marambol, di man ilang nga ang cohort is group of people, so pirates are a group of people. Pagkahuman, they say the word R. And then pagkahuman, duha ka po R, and pagkahuman, so relative risk niya. Ang usa, awa na, odds ratio na gito ang control. So anyway, that's a good way of sort of like remembering things. So I'm sharing that to you. Hopefully that will work for you as well.
Dok, pag-clarify ko, Dok, kung saan nakalagay sa cohort studies at sa kuan, Dok, case control studies ko.
Oh, na description na karon. So, ang cohort studies are clearly identified groups. These are persons chosen specifically because they were and were not exposed to one or more risk factors of the disease. Once selected, the persons are followed over time, and this can be done prospectively or retrospectively. So for example, here for the cohort study, here's our population of interest, the one who got exposed with tobacco and the one that's not exposed. And the one who developed the COPD and the one who did not develop the COPD. And in the non-exposed group, there's also a group that developed the COPD, and there's also a group that did not develop the COPD. That's why it's called a cohort study, because it's a group of people with clearly identified groups who were and were not exposed to one or more risk factors. So, ang ibutang na nimo siya sa, ikumpara nimo siya sa case control, lahi ra gyud ang case control, because ang case controls are groups that are defined as having the disease or not having the disease, but controls are often matched with cases on key factual factors. So kinahanglan nahibalo na ka kung unsay factual factors sa disease. Dili man ka pwede magka-case and control kung wala ka kahibalo sa feature sa disease. So mo nang ang main difference good, mao nang ipanganlan siya case, ay kahibalo na ka kung unsay feature sa disease. Katong cohort, wala man ka kahibalo. Imo lang gito nga gitan-aw ang na-expose o wala na-expose without knowing kung unsay feature sa disease. Pero kaning case control, naa-jud kay specific nga feature based on factual factors already. So na naka-idea maggamay kung unsa ang case. So mo nang makagamit na dayon ka og case control design. So case and control are compared as the frequency of past exposure to possible risk factors. And this is really a very good epidemiological design when it talks about rare diseases, or when you're trying to find out rare diseases, their frequencies and their occurrences and their incidence or their prevalence. So similar to the cross-sectional study in that the researchers learn about the current disease state and any risk factors that may have existed, but with the caveat that in case control, you already match with cases on key factual factors, which you didn't. This key factual factors are not feature of the cohort study. Look at the design of the cohort. It's just really the population of interest with no key factual feature. You just said, this is my population of interest, but wala jud ka kahibalo og unsay features sa disease. Wala kay key factual features sa case. So, naingon ra ka sa cohort study, these are just group of people nga na-expose og sigarilyo o wala na-expose og sigarilyo, pagkahuman sa mga na-expose og sigarilyo, kinsa man ang na-COPD, pila man kabuk na COPD niya, pila man kabuk ang wala na COPD. Kung katong mga wala na-expose sa sigarilyo, pila man kabuok ang nag-develop og COPD niya, pila man kabuk ang wala na-develop og COPD. Very different when you look at case control kay naa na kay key factual factors. So, ang design sa case control, expose, not expose, niya imong giparisan og cases. So, mo na siya diferensya jud. Ang cases are based on key factual factors. Yeah. The other here is our control. So exposed, not exposed, but no disease. So that's why it's called control. Kay na naman ta, kabalo naman ta unsay key factual features sa disease. So manang gitawag siya case control study. So sa case control study ang atong gamiton, odds ratio. Kay kabalo na gutas feature. So odds ratio gyud ang ato ang gamiton. Rate moingon jud kag pila man kabuok ang nasakit kaysa compared sa wala na sakit kay nanagog kay feature sa disease imo ko nang gi-capture nga naa kay case factual factor. So dili pwede nga relative risk ang imong gamiton. So odds ratio is the odds of an event and the ratio of the probability that the event will occur, probability also that the event will not occur. So because it's a ratio, it's basically the ratio of odds. That's why it's called odds ratio. So what are the two things? The probability that the event will occur and the probability that the event will not occur. And that's why we call it the odds ratio or the ratio of the odds. In simple terms, this can be calculated by basically looking at the number of events divided by the number of the non-events. For example, in 100 babies, the probability of a delivery being a boy is 51% and being a girl is 49. So you have the events, the number of events divided by the number of non-events. So the odds of delivering a baby boy is 51 and the odds of being delivered being a girl is 49. So you just simply 51 divided by 49, it's 1.04. So the odds, so when we interpret this, is just basically, it's just 1.04 odds or more likelihood to have a boy than having a girl delivering. So
1.04.
yes.
Kung ano, percentage to?
Dili. Ratio.
Ang
Okay. 1.04 is a ratio. Pagkahuman, in the next couple of slides, we will see unsaon pag-interpret aning ratio. Ang 1 may pinaka-perfect. So the odds ratio just basically tell us how much higher the odds of exposure. Kay duha good ang imong probability of the events and the probability of non-events. Ang pangutana ra gud na kay mao nang gitawag siya ratio kay it's the odds of the two. Now, it compares the odds of exposure to the factor of interest among cases to the odds of exposure to the factor among control. And this is how we interpret odds ratio. When we have an odds ratio of 1 or close to 1, it means that the odds of exposure among cases is the same as the odds of exposure among control. So simply put, there's no association between exposure and the disease. However, when there is greater than 1, it means that the odds of exposure among the cases is greater than the odds of exposure among the controls, and the exposure may be a risk factors of developing the disease. On the opposite side, when it's less than 1.0, it means that the odds of exposure among cases is lower than the odds of exposure among controls. And therefore, the exposure may be actually protective against the disease. It's not towards the development of the disease. So when we interpret odds ratio, our point reference is always 1. Anything above that, it means that the odds of exposure among cases will lead to the disease, and that the odds of exposure among the control is greater. And then when we have less than 1, it means that the odds of exposure among cases is lower than the odds of the exposure among the controls. And the exposure means that it could be protective because they have less development of the disease. So always remember, less than 1, it might be protective against the disease. It's above 1, it's towards causing the disease. And if it's 1, there's actually no association between the exposure and the development of the disease. So 1 is always our point of reference in odds ratio. So here are some of the really sort of like 2x2 table, and this is what I've mentioned about chi-square statistics, very easy to look at, because in chi-square statistics, the null hypothesis says that there is no difference between the expected frequencies versus the observed frequencies. So right here, you can say there's no difference between the case and the control. That could be your null hypothesis. Well, simply just putting here on a 2x2 table, if you have exposed, and those that got the disease are called the cases, but those did not get the disease are called the control. And then you also have the second group, which are the non-exposed, and they have the disease. And then those that are without the disease will become the control. So by looking at the odds of exposure, which is the cases, because we are looking at exposure here, simply you can obtain your cases by the number of cases with exposure divided by the number of cases without the exposure. So that's A divided by C. What about the odds of exposure for the control? Well, it simply expresses the number of controls, which is your B, divided by the number of control without the exposure. So non-exposed, that's your letter D. And then to get the ratio, because you have to have, the ratio is basically the occurrence of the disease with event and those without the event. And so the odds of exposure, you're going to have to do A times D, and the odds of exposure for B and C, so right here, so A and D, cases, exposed, cases, control without the disease is one of the ratio. And then the non-exposed, C times B, which is exposed and without the disease, and that's how you get the odds ratio. It's the ratio of two odds. So this is the odds of the exposed and the odds of the non-exposed, and that's why we call the odds ratio. An example. An outbreak of cyclosporiasis was detected among residents of New
Hanap
York
po ko
State.
yung internet.
In a case control study, the
Hi.
investigators found that 21 of 30 case patients and 4 60 control has eaten raspberry. Inserting this number into the 2x2 tables, you can see here the cases 21 are A, because that's 21 of 30 case patients they found. And 4 of the 60 control has eaten the raspberry. So 4 right here is the control, that's our B. And then what happens is that what's left for those who did not eat raspberry is 9, because this is 21 and we have 30 cases. So 9 are the one who did not eat the raspberry and had a case. And what happens to the control, where there were a total of 60 and only 4 of the 60 actually has eaten raspberries under the control. So you have 56 who did not eat the raspberry. And then you just simply add this number 21 and 4, that's 25 there. 9 plus 56, that's 65. You also add here in the column 21 plus 9, that's your 30. And then you also add the column under your control, that's 4 plus 56, that's 60. And then we just simply follow the rules of how do we get the odds ratio? Just follow this calculation. AB divided by BC. So A and D, so 21 times 56 divided by B and C, 9 by 4, and that becomes your odds ratio. So that's your AD and your BC. Plug in the number, very easy. 21 divided by 9 is 2.3. For the control, which is your BC, 4 divided by 56 equals 0.07. And how do we get the odds ratio? We just simply divide odds of exposure for the cases and odds of exposure for the control. So 2.3 divided by 0.07 equals 32.7. So we can read this that the odds of getting cyclosporiasis is 32.7 times more often when you are exposed. Right here, case the odds of exposure, because that's 21. It's 32.7 times more risk of getting cyclosporiasis if you have been exposed. Moving on to relative risk. So we're done with the odds ratio, which is for case control. So
I would just like also like to clarify, Doc. The result was 32.86. So there's a greater chance because it is more than 1 month.
oh, definitely. Anything above 1 sa odds ratio, dako jud kayo ang chance nga mag-cyclosporiasis ang na-expose sa strawberry kay 1 ragod ang ato ang reference sa odds ratio. Dako kay ng 32.7 nga odds ratio.
Ito.
Very good point. Yep. So, again, kato atong nahisgutan para rato siya sa case control. Nga, karon ang atong relative risk, nga atong timanaan sa mnemonics sa relative risk is the cohort, which means group of people. Group of people, ang atong point of reference ang mga pirates. Ang mga pirates, ang ilang kasagaran isulti is R. So there's 2 R's. So for cohort, group of people, ang gamiton nga statistics, relative risk. Daily case control. So what is relative risk? It's a measure of association for a cohort study. It tells us how much more likely or less likely it is for people exposed to a factor to develop a disease compared to people not exposed to the factor. Relative risk is also a ratio, by the way, just like odds ratio. But you are looking at now at the attack rates of disease among people exposed to the factor and those that are not exposed to the factor. So the ratio of incidence rate in the exposed group and the incidence rate in the non-exposed group is what we call relative risk. So it's still, we have to remember this is still at the ratio level. So how do we calculate then the attack rate? Well, the attack rate is the incidence of disease in a group where the number of people in the group who became ill divided by the total number of people in the group. So right here, attack rate is the number of ill people in group divided by the number of people in that group. The relative risk, by the way, is the attack rate for exposed and the attack rate for the non-exposed. Because remember, it is still a ratio. So it's still the way, even though it's the word, it doesn't say relative risk ratio, but it is a ratio. So just like what we call odds ratio, this should have been called relative risk ratio, but for whatever reason, they removed the word ratio. But I just want to remind everyone that relative risk is a ratio. It's the attack rate for exposed persons divided by the attack rate for the non-exposed person. So it is a ratio. So just like odds ratio, when we interpret relative risk, a perfect score of 1 means that the risk of the disease is just similar in the exposed and the unexposed group. And exposure is not associated with the disease. There's a typo there. It should read not associated with the disease. So what happens then when the relative risk is greater than 1? Well, it means that the risk of the disease is greater in the exposed than the unexposed group. So remember, they're just the ratio of the two things, the exposed and the non-exposed. What happens then if it's less than 1? Well, it means that the risk of the disease is less in the exposed group than the unexposed group, and the exposure could be a protective factor actually, because it's not leading to the development of the disease. So here's an example. If you have a 2x2 table, those who smoke develop coronary heart disease. So there's 84 of this sample of 3,000 smokers. Those who do not develop the coronary heart disease, so you just subtract it from the 3,000, so you have 2,916 because you have to add this to a total of 3,000, because remember we have 3,000 smokers here. What about the one that are non-exposed? Because remember, relative risk is just exposed, non-exposed. The ratio of exposed and the ratio of the non-exposed. So what about the lower part? Those who are non-exposed. Well, the one who are non-exposed are 87 right here. And then those who do not develop the coronary heart disease among the non-exposed, which is 5,000 right here, you just simply subtract 87 from 5,000, so you get 4,913 for those who do not develop the coronary heart disease over a 1-year period, and you have a total of 5,000. So this is your exposed, and this is your non-exposed. And it's just a ratio of exposed and non-exposed. That's what relative risk is all about. So simply put, we just look at the incidence among exposure. So 84 divided by 3,000 equals 28.0 per 1,000. The incidence among the non-exposed is 87 right here, divided by 5,000 is about 17.4. And you get a ratio, because this is the ratio of the exposed, this is the ratio of the non-exposed, and relative risk is the ratio of exposed and non-exposed. So just simply divide it by 28 divided by 17.4. So the relative risk is 1.61. So how do we interpret this? Because it's above 1.
The greater exposure of the
More contribution gihapon.
Oh, so ang
Development of
smoking
disease.
contribute good sa development
Coronary disease.
sa coronary heart disease. Kay above 1 sa 1. It's about 1.61. The relative risk of developing coronary heart disease is 1.61 higher compared to those who do not smoke. All right. I think this is about low birth weight, but it's the same concept. So I'm just going to skip that one. So this is the summary slide. Odds ratio. Always look at it as the odds. This is an example about deaths. It always includes groups such as males or females. For
Ay nara
females,
siya computation sa kuan kato mga incidence rate, prevalence rate, crude birth rate, CDR, CBR sa community health nursing.
correct. So, ang timanan ra jud lagi, ang odds ratio ra gyud, nagay case, na feature sa disease. Ang relative risk gani, walay feature, cohort ra, naara kay population, may mong gitan-aw, exposed, non-exposed, disease, ug non-disease. Simple ra jud ang
Ang amo ba kay cohort study ba na ba kay cohort study cohort study. O dito kung gamiton.
O kung mag-cohort study ang gamiton jud relative risk. Kay kung ano man interested ramang ka sa population, ay murang pangutanon exposed non-exposed pagkahuman ni develop og disease o wala ba ni develop og disease. So mara jud na siya ang algorithm sa cohort study. So So once nga maklaro na nimo kung ang algorithm sa odds ratio is katong naay case ug naay control, nya ang algorithm sa cohort, ang relative risk ang katong cohort, dali na kaayo dayan nimo i-plug in ra nimo ang mga numbers sa 2x2 table sa SPSS and you will get your answers right away. Aspas kayo malay usahay karon makalibog pagamay pero kung kuan dili naman gid paspas na kaayo ang computer mohatag sa mga answer. So here's the
Kung
final.
purchase SPSS, Doc.
So
Kung
these are
purchase ng SPSS
forever ng lifetime ang license SPSS. Kausa ra jud ka mo palit ana.
Okay.
So
Di na pwede
here's
sa antivirus nga pwede na mupalit ang usa niya, i-divide na mundo ha.
pwede jud kay ngano ang kanang SPSS usually tagduha tagtulo sa mga ni upat mga ni kabog pwede butangan og computer. Moalaw man ang IBM. So highly recommended jud katong mga nag-take bitaw og katong statistics sa first nga PhD cohort. I think nag-divide man to sila sa mga licenses. Kay ang usa nimo kapalit sa SPSS, pwede man nimo gamiton og upat ka laptop.
Kita dyan.
Kita divide ta.
Pagtunga na lang
Dyan.
mo, Mr. Acaso ni Kuan.
Kinagisod ko sa ko.
Pagtahaw man, ang kuan naman na product key naman ang imong i-plug in.
Mura siya antivirus bitaw dyan nga naay kuan pwede ta magtunga.
Yeah.
Tunga ta jud eh.
Yan na, para makasubmit na mo sa inyo ang mga assignment. Sana na yun. Saan na yun nato pang ang next week raba puro narabadayan na SPSS na to na to produce na mga descriptive statistics, i-produce ang mga tables, i-produce ang mga saan na to pag-produce ani sa to ang mga bar graphs,
na lang ni Dr. Tariman. Pag-share to sa license ni product key ni Dr. Tariman.
Ayaw taon.
Joke Doc.
Bawal na ako diri nga mag-share sa mga kuan estudyante. Daghan kayo mga kuan pero kamo lang I would say kung kuan best investment na ninyo.
Kapila okay. Miss Mantos.
Nanas Miss Mantos ko ni submit na goods Miss Mantos.
Nangayo siya sa itong
previous. Yumi palit gid siya.
Magningay siya sa previous dali o di ko sure. Basta magnasay na nasi kaila daw.
Nana siya kaila kay faculty man siya si Budok niya. Daghan man kay itong mga namalit sa si Budoctors nga faculty. Pwede po nga tawagan to ninyo itong mga ingna si Ma'am Tess nga. Ma'am Tess, kinsa man to yung mga nagpromiro nga kuan, nagpromiro nga statistics niya. Pangayo, pamaray gilang good nga. Pangayo ang product key. Product key raman jud. Once nga na kay product key mo, function naman dahil ng SPSS.
Wala dahil na expiration?
Wala na siya expiration jud. Lifetime gid na nga licensing. Kausara jud ka mo palit.
Malit na lang ta dyan, oy.
Kung alam ko na ninyo, good, 3 mil kapin, tag 1.5 lang mo. Investment na ninyo.
May asa mo ito, malit, anak.
Sa Amazon man na, Amazon.
Naaro sa IBM, kato akong gisa ni John sa website.
Kato ilang website.
Kato rang kuan, normal rang kuan, standard rang
ikaw lang palit dyan. Matag lang ko.
Nya legitimate man na ang kuan ang website kay US man na siya diretso. So dili man na ingon nga makuha ang inyong kuan credit card or something ma-compromise ang kuan bitaw. Ang number.
Yung mga card gamit ta dyan.
Ikaw lang dyan kay niadto bitaw ka og kuan nagsurog
nagsurayala ato kog binahan wala ko. Sa internet ay ko makakuan ko ba.
Yeah. Mas ang kuan lagi pod na may uban pod nga nasa ayala nga mamaligya gid og disk. Nga naanadaan ang product key didto. Onya.
Pila man
pwede nimong kuan
$3,000 ka po din.
Pila dyan?
3,000 tapos murag huwag ko bukas sa dapita sa ayala pod. Mangitan ko sa ayala.
Cannot be more than 4,000 kay tag 60 rabo ng licensing diri sa States. $60 to $70 times 40. Di ginamabot og 4,000 ang mopalit ka og CD nga SPSS nga CD. Nya pagkahuman kanang CD bisag asa na nimo dadon pwede na nimo i-install up to upat ka laptop kay sa ako walang daan usa sa akong personal nga computer, usa sa akong opisina, ang usa sa gi-issue sa DePaul. So I'm 100% sure tulod yun nakabuka kung nabutangan sa ako ang SPSS nga license. So I think up to 4 na siya nimo pwede ibutang ang kanang CD nga kuan SPSS. All right, so tigwaso na ni nato ha, discussion. Both the odds ratio and relative risk show that men were more likely to die. The odds ratio showed that men were much more worse off. But katunaning sa mga examples sa that, which we don't need to look at that. Last na nga concept kaning absolute risk. Absolute risk is the risk of developing something over a specified time period. Sometimes it's your lifetime. Just like, what is the absolute risk of someone to develop lung cancer if they have never ever smoked in their lifetime? So it's basically a probability that lung cancer will occur in a very specified time period. The same absolute risk can be expressed in different ways. Daghan ni siya pwede nimo gamiton. Ang terminology, murag usab-usab lang gamay. So if you have 1 in 10 risk of developing a certain disease in your life, this can be stated as a 10% risk or as 0.1 risk, depending on the use of the percentages or decimals. If the risk of developing a disease was 4 in 100 in non-smoker, you can say the relative risk of the disease was increased by 50% in smokers. But what is the absolute risk? Well, the 50% relates to the 4, so the absolute increase in the risk is 50% of 4, which is 2. So 2 is the absolute risk of developing the disease. And then this increased to 600 in 100, or 100 of people in your calculation. The next one is the number needed to treat. This is what we call NTT. This is very controversial. This is actually the concept that led to disagreement about unsa gyud sakto nga frequency nga mag-mammogram ang mga women. Kay they have calculated that para makuha ang benefit, kinahanglan X amount of people has to have mammography. So kung mingon ka nga, ang number needed to treat is 3,000 in order to get the benefit of detecting 5 abnormal mammography. So kung walay nagpamammogram og 3,000, actually, dili nimo ma-realize ang benefit nga makadetect siya sa disease or sa cancer of the breast. So mo na nga controversial jud ni siya kaayo ning number needed to treat. So all I can say is that the number needed to treat sometimes becomes the argument nga ngilngiga oy manginahanglan day tag 3,000 ka babae nga magpamammogram aron lang nato ma-realize ang gain nga makadetect siya 5 ka buok nga breast cancer. Nya pila may gasto anang 3,000 ka women ang gimammogram. Is it worth the expenses nga kinahanglan nasa gyud 3,000 ka na babae nga nagpamammogram aron makadetect ka og 5 ka buok nga breast cancer cases? So mo na nang daghan na kayong argument nga well maybe dili na gid na siya advisable nga magmammogram ang tanan katuna lang na high risk feature maoy mammogram.
Pero dili sa di siya makonsider nga bias sa research.
Dili sa dyan na siya considered bias kay gitan-aw man dyan na nila gid nga pila man ka buok ang kinahanglan nga nagpamammogram para makahibalo ka nga tinud-anay gid nga nakadetect og breast cancer. So mo na siya ang concept sa number needed to treat. So mo nang nangausab ang guidelines sa breast cancer tungod ani nga concept is the number needed to treat. So that's pretty much it. And if you have any questions, please feel free. Basta Manila jud 2x2 table, nominal, kay disease, without disease, exposed, non-exposed. Ang perfect nga statistics is chi-square statistics. Nigabot na to sa second level sa statistics na logistic regressions. Dayon kay ang logistic regression is all about yes, no, mampud. So mo na siya ang pinaka the best nga statistics when it comes to it it's called the binomial variable. So, exciting, but mabot ra punta dito. All right. So, the rest na ha, puro na mga assignment. Dili na ko mag-lecture. Kamu na dayon may magsigig hands-on na lang.
Ano yung last na ito na lecture, Doc?
Oh, last na ni nga kanang in-person ba? The rest, isynchronous na. Pwede na, ipadala na nako tanan by video, nasa YouTube, or nasa ko ang kuan, ang akong Gmail, connected man na sa YouTube niya. Ipadala na ako, daghan na kay kog mga video lecture nga naana na kabutang sa YouTube.
Pero nami question, Doc. Pwede rin mo email nimo.
Of course. Phone a friend, phone a professor anytime. Kay basin niya walo nakakauras nagsigig lingkod sa imong SPSS niya buka man wag pon masolve ang problema. Mas may bang mag-phone a friend. Ang rule. Kung di ganin mo masulbad ang SPSS nga problem in 1 hour, it's better to call na your friend.
Nag-solve ko sa SPSS, nag-input na ko katong column variable nga dito. Abot na po instruction dito sa katong photocopy katong PDF nga you have to click the lower right corner and then do the thing. Wala ko kasabot natuog na lang ko.
Phone the friend din kasi Mrs. Mantos din imong tawagan kay daghan man silang mga nag-uptick na kay na sila mo himog SPSS. Ana ra gyud na kay ang kani man kong SPSS skills man gud.
Basta makaon na lang.
Skills man gud na gud niya kanang skills. Di ba makat-on man kita kung naay mo tudlo na to sa skills pareha gud sa nursing skills gud nga kung tudloan ka unsa ang pag-catheter ang kuan dali ra kay ka maka-cut-on og catheterize og women kung pakitaon jud ka kung unsa ang pag-catheterize ang women sa theory ra gyud na siya na morning kuan asa ang urethral meatus nya just a little bit superior to the vagina, but all of that are just words. Dahil radyo nang kit-on jud ka, kung time na nimo nga ikaw na may mo kuan mo catheterize, dali ra kay mainumduman kung gi-demonstrate gid sa imo ha. So it's the same thing ra gyud na sa SPSS. Kung nalang gyud maka-demonstrate nimo, dali ra kay ano ang SPSS.
Pero katay mo short nga video nga gi-send lang this afternoon, Doc. Nato dito ang demonstration nimo.
Nato dito jud unsaon ra pagbutang.
Doc, ako'y pangutana sa imo, Doc, kabaw ka ng mga intellectual property? Kanang, I don't know, is it alright pananglitan if naay, like si Akaso, Mr. Akaso is, naa siya sa ilang hospital, nag-work siya, ikaw may nurse educator dyan, no? Unya pagkahuman ako po nurse educator ko sa among hospital pananglitan lang. Unya but your hospital panan is tertiary nya ako nagwork ko sa provincial lang. Ako sa mga secondary lang ko. Unya when I came to visit sa imong hospital nakakita ko sa imong mga checklist, mga evaluation checklist, nice siya kay tanan. And ako mismo kay pamango kay naman ko sa province ni ask ko permission sa imo can I do the mo benchmark ba ko pwede na siya
pwede basta with permission anything intellectual property basta na kay permission pwede gid na kay I did ask one manggodok niya just the sort of like point of reference nga benchmarking lang ba I will yeah, I was told man nga dili man pwede kay intellectual property magud na naghim kami magud naghimo ana. So wala lang po ko namugos. That's not true. Knowledge, nobody owns knowledge. Nobody owns science. You ang imuha nga makat-on ka sa ilang gibuhat but you're gonna have your own data, you're gonna have your own project. So similar pero actually may mag-imong gikopya ang ilang data padung sa imuha. Ang imo ra man gikuan nga ang skills man o ang method mo imuhang
like when I saw the checklist kanang pananglitan checklist sa kanang tracheostomy care nya ang sa amo wala man mi sa una ana diri sa among school. Nya I wanted although na aming uban checklist sa amo but then we kanais man pagkahimo sa ilang checklist nya can I do the benchmark lang kay mo tan-aw lang ko nya. I was told man nga dili daw allowed kay nag-sit down daw silang tanan-ana na intellectual property. Ano yung I understand, it's okay.
That's the first time I've heard kay there is a states mo develop ka og mga tool. It's an honor if people will ask you, can I use your tool? Kay nagpasabot nga kasi states ra ba gyud ang imuhang prestige is based kung pila ka tawo ang nigamit sa imuhang tool.
See?
Magpasalamat sila nga giganahan ka kay nagpasabot na nga na good job. Diri sa Amerika, magambak-ambak in town mi kung naay mo ingon ang mga Spanish, ang mga Chinese nga pwede na mo i-translate pareha na ang katong akong acceptability scale nananghid ang French nga ilang i-convert into French. Siyempre, yes! Kaya it's an honor nga nimuhang...
Ano yung manggulkudok nga, the success of a certain kanang kuan, like pananglitan, if you want to become a good department or a good college, you should benchmark from the best colleges for you to become better. So then, how come nga, ang uban, murag selfish lang?
Kanang intellectual property, kung gusto ka magpabayad, kung gusto ka, sige, pwede ka mong gamit, pero bayad kag 100. Ano na gitawag intellectual property? Kay bayaran mo, magpabayad man ka, una magamit ang ilahang tool. So, tinuda na nga, na-exert sila na intellectual property nila ko, una ni mo magamit, bayad sa ka, kaya ako gawin naghimo. But here in the States, wala man, dili dyan na yung ang kuan man good, very good, ang benchmark mo sa state sa mga professor, ihapon pila ang Google Citation Index. So, i-Google niya ang akong Joseph Terman Citation Index. I-benchmark man ka sa ubang professor kung unsa ka kasikat. Pila man ka tao ang ni-cite sa imuhang work. So, manang gitawag og citation index. The higher is your citation index, the more kasikat. Manang dili jud ka mo say no. Nagani mananghid nga mo gamit sa imuhang tool. Yes, yun na kay that means i-cite nila ang imuhang work sa ilahang next publication.
Niwan na lang ako, maghimo na lang ako akong tool.
I wouldn't advise that one. You do not reinvent the wheel. Pero yun na diri, kung naana gani nag-develop og tool, ingnon jud nako kung estudyante. Ayaw na pag-develop og bag-o nga tool. Kaya na may tool nga na-develop sa uban nga mga school. Ang imuha na lang nga, mananghid na lang ka nga gamito ni mong ilahang tool para sa imuhang study. Kay mo-develop kag imong kagalingon, yung pagkaman redundant naman. So that's not good. It's not a good use of your time. Mo-develop ra gyud kag tool kung wala pa naing naka-develop. All right. Nahala, sige, I'm looking forward to all your homeworks and your assignment. Yeah, pagkahuman, di gani masabtan, email lang yun na ako, text. Kay, may email actually, akong phone, pero mamintig yun na nasa akong kilid niya. Pagkahuman, automatic man lang, makitaan mo na yung mga email tanan sa phone. So just email me. It's
Dok, lagi mo reply nga laing email, imo gihapon to? Nga naka-connect sa yung school.
Gmail.
Pero dili man Joseph Tariman ang nakabutang.
Joey Damiao, because that's my nickname.
Kinsa to, nanawala na ko.
Joey Damiao ang kanang sa akong Gmail.
Yeah, kinsa na siya